Alright, so now that we have basically spent some time looking at how to factorize and how to solve equations and do some harder questions using sum and product, we're going to actually start to look at how the functions work and solve some real life problems, etc. So I would probably get a highlighter and highlight as you go and kind of write annotations on your booklet as you go, because I've already printed these all out in the booklet section, so you wouldn't have to write it in your book. So a quadratic function is when we have y equals ax squared plus bx plus c. Now it is very important, similar to the quadratic equation, that a is non-zero, because when it is zero, then your equation just ends up being a linear equation. So very, very important that a is not zero. So that is a condition that comes with the quadratic function as well. So there's a couple of ways to obviously draw kind of quadratic function. It's obviously going to be a curve, a parabolic curve. So it's going to have these two shapes. Okay, so it's going to either look like this. We call this a parabola. So I would highlight that. We can obviously, if you get a table of values, you can use those coordinates to draw it, those dots, and then connect it. And then obviously write your equation, etc. So this is a very simple graph, probably the most simple. Y equals x squared. That's what it looks like. The parabola is one of the conic sections, which are the group of curves obtained by cutting a cone with a plane. So as you can see in this image here, it's just an explanation of a cone cut into a section, and you can see that if you look at it from the sideways, if you look at it from this angle, it will give you a parabolic kind of shape. So a parabola is produced by cutting the cone with a plane parallel to its slant side. So slant is this, so parallel to that. By cutting the cone at other angles, we can produce things like circles. So for example, if I cut it like this, I'll be able to see a circle, hyperbola and ellipses, etc. Real life examples, you can see there's all of these images have parabolic shapes in them, so you can maybe highlight it and draw it kind of thing. And yeah, so you know it can be applied in different scenarios and situations. A little bit of terminology, hopefully we know most things. So we know the x-intercepts over here, we know the y-intercepts over here. This is called the minimum spot. Obviously if the parabola is going the opposite way, we'll have a maximum. Now, at minimum maximum, we call this coordinate a vertex, so that is a coordinate. So you should be able to write the coordinate, and we call that a vertex because it's our minimum spot or the maximum spot. One more thing is called this axis of symmetry. So basically the x coordinate of this, so if I just name it, if I just call that coordinate -2, x coordinate is -2, I just made that up, and then maybe let's say -10 for the y coordinate. The axis of symmetry is just basically where the parabola is symmetrical, so a line can be drawn, and that can be given with an equation x equals -2. The reason being is because the x coordinate is -2, and that vertical line is represented by the equation x equals a number. So x equals -2 is the equation of axis of symmetry. So that'll depend on what the coordinate x coordinate is. So we call it a parabola. If you know the equation of this, we would obviously write it next to it as well. So these are the things I'm kind of expecting on a graph. So we've got our quadratic function, and we have the point where the graph turns is called a vertex. If the graph opens upwards, it is called a concave upwards graph. So that's just what we call the shape. So this shape over here, it's called a concave up. And then this one over here is called a concave down. I think of it like, this is a cave. It's going downwards. So this is concave downwards. And then this one's the opposite. It's a cave. We call that shape a concave. And then it's just going upwards. So those are two names we kind of describe the parabolas with. So, the positive one's going upwards, concave upwards. The other one's concave downwards. Just two terminologies for you to be familiarized with. So one will give you a minimum, one will give you a maximum turning point. So we call them a turning point, or a minimum, or a maximum. The vertical line that passes through the vertex is called the axis of symmetry. I've mentioned this just before. The value of y where the graph crosses, we already know that's a y-intercept. We already know what an x-intercept is. And x-intercept can also be called roots, zeros, etc. So all those words are interchangeable, and I'll be using them, or the questions will be using them interchangeably. Alright, let's move on. There's three kind of different quadratic forms you need to understand and be able to transfer things out of. So let's say we have this quadratic form where it's basically in brackets, it's factorized form in two kind of linear factors. So this can tell me two things. This can tell me that, because it's a minus p, if I use null factor law with these two brackets, I should have my x-intercept, my zeros at p and q. So if I solve it, I get basically my x is equals to p or q. So that's why it corresponds to the x-intercepts on the graph where I've highlighted it. Now this axis of symmetry, we should actually be able to easily figure it out even if we don't know the vertex, because if you think about it, it's halfway between that line. So if we add them together and then divide it by 2, so we're averaging it, we should be able to find this coordinate, the x coordinate of it. So these are some facts we like to use when we have basically this format, when it's just two linear factors. So these are the facts. Just come back to it. Obviously highlight it if you want to, or just leave it. X-intercepts are P and Q. Axis of symmetry is always given by adding the two x-intercepts and dividing it by 2, so finding the average, meaning the vertex will have the coordinate of P plus Q divided by 2. So because I have the x coordinate of the vertex, technically I should also be able to find the y coordinate of the vertex as well by substituting it back to this equation. But we'll talk about that maybe more in the examples. This is called perfect squares. So we've got perfect square, two brackets that are the same. So this one will give us, so if I use some terminologies, this is called cutting the graph. Cutting the graph over here, and this is touching the axes. So those are the two words. If it has a power of 2, it's going to be touching the x-axis. So it touches the x-axis at this coordinate h, because that's the linear factor. Because it was a minus h, it'll be touching at positive h. Axis of symmetry is x equals h. And then vertex will be h, 0. So there we go. Now, in this case, pretty similar to this format, but you can see that there's an additional plus k. And this is kind of from a, what was it called? Solving by completing the square, that one. So if you solve by completing the square, you should be able to kind of rearrange it and get it back into this format. And then if you have that format where you have a factor square and then a plus k, you should be able to actually summarize that the axis of, the vertex is h, k. So if there's a bracket, whatever that minus h factor is, that will be your x coordinate. So you obviously inverse it. So if I find the null factor, I go x take h equals 0, so x must equal h, so that becomes my x coordinate of the vertex. And then, funny enough, this is the rule, this k value, this constant, whatever it is, or if it's a plus k, it's going to be a k. If it's a minus 10, it's going to be minus 10. If it's a plus 5, it's going to be a plus 5, etc. So if it's already in this format, you should be able to easily find the vertex by just reading that number and that number. So that's pretty much it for that one. So a couple of things you need to know, coefficients. So this a corresponds to kind of the shape. If it's greater than 0, if it's a positive number, basically creates a concave up. If it's a negative number, smaller than 0, it's going to give us concave down. So if a is between -1 and 1, and a is not equal to 0, the graph is wider than the y equals x squared, so you can just use that as a reference. If a is less than -1 or greater than -1, the graph is narrower than y equals x squared. Most of the time, you're just going to be using this first dot point as the main resource. So let's try example 11. Using axes intercepts only, okay, so meaning x-intercept, y-intercept, sketch the graph of. Okay, so I only want to know those things. I don't need to know things, every other coordinate etc. So let's find those x-intercepts first. Well, by looking at this formula, I already know that just using null factor law, I should be able to go, well, that could be 0 or that could be 0. So if x plus 3 equals 0, if you want me to do a little bit of working out, x must be negative 3. Or if x take 1 equals 0, or x must be 1. I'm just kind of doing the algebra there. So my x-intercepts, if I write it a little bit lower, is when negative 3 or 1. Lovely, now I just have to find my y-intercept. In order to find my y-intercept, all I need to do is substitute my special condition, x equals 0. So it'll look like y, let's just do a little arrow there, y equals 2, bracket 0 plus 3, 0 take 1, so it'll be 2, 3, negative 1, so that'll be negative 6. So those are all my intercepts, so all I have to do is draw them. Now I'm just going to do it just roughly to scale, so negative 3 over here, 1 over here, and then negative 6, let's just say it's over there. And I need to also know if it's going to be a concave up or a concave down graph. So in order to do that, this is how you would do it. When I basically figure out the coefficient of x squared by expanding all of these factor, I just need to find the coefficient of the x. So what I would do is I would go, oh, what number is in front of the x? So if I times this one, and this one, what number would it be? It'll be 2x squared. So I don't even have to actually expand it all. I can just choose which one's going to be. So 2x squared is going to be my coefficient for the x squared, so a must be 2, meaning if I go back to my notes, it's going to be this dot point over here. A is greater than 0, so it's going to be giving me a concave up. So it's going to be this option over here. So I just need to be able to draw that in, try to draw it as symmetrical. Obviously, if my x-intercepts minus 3 and 1, the halfway between that would be negative 1. So it's just my halfway point. And so something like this, let's have a look. And then it is also always important for you to label those. So I've labeled my y-intercept, x-intercept, x-intercept. I'm going to write my equation that I drew in as well. Always, whenever you draw a graph, if you know the equation, write it down. And to finish it off, you know you should really write x and y. Right, that's a perfect graph. Alright, let's move on to B. So again, I'm going to find my x-intercept first using null factor law. So just looking at this bracket, I know that x is going to be 1. Looking at this bracket, I know that x is going to be 2. Hopefully you've had enough practice to do that, and I don't have to explain it further because we did it in previous sections. So x-intercept equals 1 or 2. If you're still not understanding how to use null factor law, please do raise your hand and let me know so I can come and help you. So I've got my x-intercepts, now I need to find my y-intercept. Y-intercept, I just need to substitute my special condition x equals 0. So therefore y equals minus 2, 0 take 1, 0 take 2, minus 2, minus 1, minus 2 would be 2 times 2, so minus 4. So using all of those information, I'll draw it in. So I got 1 or 2, so I've got 1, 2, I'll label those, and then I've got a minus 4, let's say over here. So vertex is going to be approximately there, it doesn't have to be exact. Oh, I should probably check that it's going to be a concave or a convex before I just assume. Let's have a look. So if I times x, and a minus 2, it's going to give me minus 2x squared, meaning that's my A. Meaning, I go back to my notes and have a look. Well, A is this option, so A is less than 0, so it's going to give me a concave down. So I just like to write that note in my kind of notes before I get on. So I know that my equation or function would look something like that. If I can get it to connect, I should really try to. There we go, that's good enough. I'll add that in because I accidentally erased it. And then write my function, y equals minus 2, bracket x take 1, x take 2. Brilliant. Alright, we've got one more to go. C. Okay, so we've got a half, bracket x plus 2 bracket squared. So same thing, what is my x-intercepts? There's only one option, it's going to be x equals minus 2, it's just touching the, because there's two factors of it, it's minus 2 or minus 2. Y-intercept, I just have to substitute my special condition, so it'll be y equals half. So it'll be half times 4, half times 4, which is 2. So my final one looks something, I need to figure out my A. I'll do that in just a second. Okay, let's find out my A. So if I times x and another bracket of x and a half, I get half x squared, so therefore my A is going to be half, meaning that it's going to be a concave up graph. Basically, anytime that's a positive, it's a concave up. So negative 2, so let's say that's negative 2. Y-intercept's at 2, so it's going to look something like this. And then I just write my function y equals half x plus 2 squared. Alright, there we go. So copy that down, and then we're going to do this one. So you can do some questions if you want to. Obviously, just have a look at the checklist of what I've got, but you can do question 1 to 3 now. Have a go at that first, and then this is going to use some harder kind of parts. So example 12, use a vertex, axis of symmetry, and y-intercept to graph that. Okay, so it's going to be vertex. So again, this equation looks like my third dot point, so I'll just quickly have a look at that. So looking at all of these notes, I'm going to get rid of all of that. Looking at these notes, all I need to do is find my h, k, the vertex, and then just use the x coordinate as the x coordinate of that as your x value of the axis of symmetry. So let's give it a go. So if it's a negative h, it becomes a h. Whatever that constant number is becomes your y coordinate. So that's all I need to do. So looking at this, I know that, it's a plus 1, so it's going to be negative 1. It's going to be plus 4 as my, I'm going to write V for vertex. So axis of symmetry, I'm going to write axis of symmetry, that's good enough for me, you can do that too, is going to be x when x equals negative 1, because we always just use that coordinate. Y-intercept, if I want to find y-intercept, I just substitute in x equals 0. So let's do that. Minus 2 plus 4 is 2. Now I just need to figure out if it's a concave, concave up or a concave down graph. So what I need to do is I need to expand that out with another x. So my x squared coefficient would look something like this. Therefore, minus 2 is my A, and therefore it's going to be a concave down graph. So let's give it a draw. So I've got my vertex. So negative 1, 4, so let's say that's negative 1, 4 over here. And then my y-intercept is at 2. That's my y-intercept. It doesn't ask for x-intercept, so I'm just going to have to assume. But that's my axis of symmetry. I'll draw that in physically as well. X equals negative 1. And then I can draw my graph. Like so. I'm going to try that again because I didn't like that. There we go. And then I write my graph. That looks more like doesn't look like a curve. So I'm going to retry that. That's good enough. Y equals minus 2 plus 1 squared plus 4. There we go. Alright, so you should be able to do every question in 2D.1 now.